All right. Good morning. Welcome to today's Safety Connection. My name is Don Patton, a specialized consultant in ergonomics with WSPS. I will be your host today and presenter. With all our safety connections, just a brief housekeeping items to go through for you. So firstly, we recommend you use your computer audio with headphones, but certainly phone conference audio is available. The phone conference audio details can be found in the access email that you received prior to this webinar. Your camera and microphone will remain off for the remainder of the session. To submit questions and communicate, please use the meeting chat. The chat is public and can be seen by all participants. With this meeting, you have the option to use reactions, as somebody just did, which is great. Access in the menu bar. Reactions are instant and will float up on the screen. As you can see, we will be asking poll questions throughout this webinar, which will pop up on your screen and or in the meeting chat to the right. Please select your answer and select submit to participate in the poll questions. Dependent on your organization's security, may not be able to interact with poll questions. If you determine this is the case, we ask that you participate in the chat if you wish. The meeting chat is accessed in the menu bar. Messages can be sent in the chat at any time. And as a reminder, the chat is public. Microsoft Teams offers two accessibility features which may be of use. To enable live captions, select More from the menu bar, Language and Speech, and then turn on live captions. To enable full screen mode, select View from the menu bar, More options, and then Full Screen. Both features can be disabled by following the same instructions. If you have any technical difficulties throughout the webinar, please send a message in the meeting chat or respond to the access email you received. Uh, the Safety Connection program has four main goals. One, to learn, share, and discover what is of value to you, our customers, and our community, to connect virtually with industry peers, to facilitate a best practice exchange, and to provide an opportunity to attend a health and safety webinar from your personal workspace. Okay, all right, so we got through that. I just want to set the agenda for today. So we're going to be talking about mitigating risks in main and materials handling. And there's kind of three aspects that I want to go over. I just want to do a brief introduction and information about why MSDs occur. I know that the information about MSDs has been out there. We have great resources on MSD prevention with the MSD prevention guideline, a bunch of different things as well. But I just want to kind of go through that because what I'd like to accomplish at the end of this session is really just to give you some, like understand the challenges with manual materials handling. Why do they keep happening despite the fact that we have all these resources, and try to give you some practical strategies. And if you can think about that throughout this safety connection, and as we have conversations, or at least try through the chat and different polls and that sort of thing, of any either any challenges that you have or any practical strategies you've discovered in your workplace that maybe you can share with others during the safety connection would be great. I do have some that we've come across in the past that I will share with you a little bit later on, but really just getting to the root cause of why these MSDs occur, that's going to help us understand really where our challenges are, and to understand how to apply some really practical strategies to eliminate some of these issues. But before we get to that, we have our first poll question. I'd just like to know what industry you're from. Perhaps that will help us with some examples and try to relate some of the content to your industry. So if you don't mind answering the poll, that would be fantastic. Okay, let's see. Okay, pretty good response here. So if we close the poll, that would be fantastic. So I see some of having issues with audio and um, some of the poll, and that's fine. I'm glad that you're putting it in the chat as well. And it looks like Cindy is there to help me with the audio. So that's great. Thanks, Cindy. Okay, so we have a mix for sure, which is great. So we do have some case studies and some examples from all of our sectors, see healthcare there, metal stamping and manufacturing, all those types of things. So that's great. So we'll try to provide those industry specific examples. But the thing with MSDs and ergonomics and that sort of thing is that the hazards that you would identify are the same across those industries. So, when you're dealing with MSD hazards, it's just a matter of, in your unique situation, your environment, understanding, what you're doing and what activities you're doing that are going to lead to those hazards and helping you to identify. So you may kind of know this stuff already, but I like to go through it just in case you don't. And it's a good reminder of, particularly with manual materials handling, is really understanding what is excessive force, right? So I know we may be pushing or lifting heavy things. I mean, lifting probably, for most people on the call, for example, might be pretty straightforward. Like if you're lifting something that looks really heavy or awkward, then that might be easier to pick up. But what is excessive when I'm pushing like a pallet full of boxes, right? Or pulling, and what does that do to our body? So we're going to talk a little bit about that, certainly about posture and really what constitutes kind of an awkward or a non-neutral posture, the importance of identifying, static postures. And then of course, one of the more difficult ones is really what is repetitive, really what is repetitive. So, you could argue that doing an action more than once is repetitive, but what does that mean with our body, and how do these things interact to create, the hazards to the point where injury occurs? So let's talk a little bit about force. So of course our muscles need to use force, right? We need to generate force to do any kind of action. When muscles are using too much force, it can cause injuries to the joints, nerves, tendons, and other tissues. And when you look at definitions of MSDs, I mean, that's generally speaking what we're looking for is injuries to those joints, nerves, tendons, and other tissues like muscle fibers and that sort of thing. So, I always kind of relate it to, using elastic. And if you take an elastic and you stretch an elastic out, you're applying force to that elastic, and you know that if you stretch it just a little bit further than kind of its end range, it's going to start to fray and snap, right? So that's essentially what happens. And you can see in this graphic here is that's really what what happens in some cases when you apply a force to a tissue. So a tissue like the muscles, for example, might start to fatigue, and you can kind of see how that yellow line is straight, but then starting to bend down. Well, if you apply force for an extended period of time, that tissue can fatigue and then injury can occur, right? So that's one example of kind of a very high force in low reps, for example. So you have that low constant force without rest, right? Another example, you can have a tissue tolerance. Let's just say that your muscles can handle, let's say 50 kilograms, just for argument's sake, 50 kilograms of force. Well, if you apply 55 kilograms of force, you're exceeding that tolerance, and that's when injuries can occur, right? So again, you take an elastic, you stretch it, you apply more force to it, and injury occurs. So kind of if we skip the challenges a little bit, kind of a challenge with manual materials handling, identifying these hazards is that, how do I know that tissue like we're not expecting people to measure tissue tolerance, but there's some uniqueness here to the human body and how that how that occurs, and how we're applying force to our body that may result in different types of tissue tolerance for different types of people. So there is some challenges here, but what I'd like to do a little bit later on is try to give you some examples and some practical strategies to help you identify really for the majority of individuals where that force starts to cross that excessive line for you. So we'll talk about or have some discussions about that a little bit later. But of course, for manual materials handling, some examples: lifting, carrying, pushing and pulling. We can extend that to tool weight. If you have a tool that's too heavy, that can apply, force to your arm, or you have to grip, more to support that tool weight, and increase grip force to do that. If you're inserting things, you're using your thumb, for example, to insert some things in there. Some examples are pushing buttons, right? So different examples of applying force in the workplace. So awkward postures or static postures. An awkward posture occurs when we, whoops, sorry. An awkward posture occurs when we bend, reach, or twist our bodies to do the work. It increases the amount of force on our soft tissues like muscles and spinal discs. So, of course, the further away from neutral the body is, the greater the risk of injury. So, when you think about, safe lifting techniques, for example, when I'm sure everybody knows, bend your knees and keep your back straight. And one of the reasons why we want you to do that is that keeps that load close to you. So, if we get further away from neutral, so if I take a box and start lifting it out here, then that's putting more pressure on my back. So I'd like to keep that box as close to me as possible, and that reduces some of that pressure on my back. So that's why we have those safe lifting techniques the way they are, is to try to keep the body in a more neutral position. Because as we get into a more awkward posture or more kind of non-neutral posture, that puts a lot more pressure on our joints, in our elbows and wrists and hips and back and those types of things. So, when we're looking for hazards and we're doing risk assessments and all those types of things, a lot of times when it comes to postures, we're looking for non-neutral postures. So with my wrist, for example, like, I can have a straight neutral wrist, but if I'm bending my wrist, I can't really apply a lot of power in that kind of flexed position. So, I'm going to have to generate a lot more force to hold that tool, and that's going to put a little bit more pressure on my wrist, which could cause an MSD. So those are the types of things as an ergonomist I'm looking for to try to reduce risk. So that's why we say, if you keep your wrist in a neutral or straight posture, again, it's just helping to put yourself in a more mechanically advantaged position, right? You can apply, less effort, but get the same result when you're in a stronger position this way. So that's why we kind of look for these awkward postures and determine what types of changes can we make to the work environment. How can we change how the person's working that could result in a kind of relaxed or neutral posture. So those are the types of things that we look for. And when it comes to identifying hazards with manual materials handling, that's essentially what we're doing, right? Force is sometimes, a little bit more of a challenge to see, how do I know that that's a force if the muscles are generating force? Like, how do I measure those types of things? And sometimes we look at, you know, like honestly, we look at a worker's face to see if they are grimacing or they are, applying effort, or you can see them tends to do that because it's kind of exceeding, a comfortable level of what their capabilities are. So, in some cases, that's what we're doing. We're looking at those types of things. We measure push and pull forces with force gauges, and we have different types of tools to try to quantify risk based on weights and like I said, push pull forces and all those types of things. But at a basic level, to identify really what is a forceful exertion, we can look at somebody's face, for example, to see what type of strain they're under, and same thing with an awkward posture, right? We know that neutral is the best, and it's less risky. I'm trying to organize things in front of my camera here, but so you have it here, and if you bend your wrist, we know that you're weaker in that position, and you're more than likely going to develop discomfort in that position. So these are the types of things we observe and we like to see, or we don't like to see, but we like to observe when we're trying to identify some of these awkward postures. Uh, As far as repetition goes, repetition is the use of the same body parts continuously to do a task. This can tire the muscles and hurt soft tissues, especially when it's done with little or no rest. So, with MSDs, generally speaking, it's a combination of hazards. So, if you think about this as an example, so, if everybody wants to take their hands, I'm trusting you're going to do this, but if you take your arms and just reach out, in front of you, just above shoulder level. So just reach out in front of you like this. And I've done this example lots of times if you've been on Safety Connections with me before or training. But if you put your arms out in front of you, so what is happening? I'm in a a non-neutral position. I'm reaching, and now my muscles are having to apply more force kind of in the shoulders. And then what happens over time is my muscles start to fatigue. And that's more of an example of a static force where these muscles are continuously um, contracted to hold my arm in this position, right? So I'm doing this position. Well, if I need to do that and reach and grab something, and then do this and reach and grab something, then you start to see the effects of that repetition, and that fatigue starts to build up in the shoulder. So generally speaking, you start to see a combination of those hazards leading to that discomfort, right? So I got an awkward posture. I'm generating more force to keep my arm in this position. And then if I do have to do it repeatedly, then you start to see that fatigue build up over time, especially if there's, as it says on the screen here, with little or no rest, right? If I don't have time to recover, then the next time I do that action, I'm going to start to create more of that, right? So, but with repetition, the problem is that on its own, we find that just doing repetitive activities really with little to no force, or well, just little force, there is going to be force there, but just little force, or even if you're kind of in a neutral position, then even repetition itself on its own to a certain degree can lead or potentially have a chance to lead to an MSD, right? So repetition is one of those things that we need to really keep an eye on when it comes to how many things we're repeating over time, how much we're asking our muscles to work without that rest. So we'll talk about that when we get into some solutions about how we can kind of mitigate that, and how we can kind of reduce some of that fatigue. Okay. So why do we get injured? And really, quite frankly, we have limits, right? So I think what happens a lot of times when it comes to manual materials handling is we have processes and machines and storage systems and all of those types of things, all of those requirements that we need to get material from whatever we're manufacturing or growing or producing, or I notice some people in the service industry, same thing, like if you're housekeeping or serving, a serve in a restaurant, like you're handling these types of materials. So at some point in time, humans are required to do the things that are difficult for machines and robots and forklifts and those types of things to do, right? At least for now. Um, so we just have limits. So when we're dropped into, as humans, we're dropped into that scenario, we're limited by what we can do. And of course we can only hold our breath for so long, for example. We need that oxygen to create energy, to be able to get rid of waste and all of those types of things. And it's the same with work, right? If we are working and we are working at a high level to where our heart rate is up and we're starting to fatigue, I mean, there's only so much oxygen we can ingest and process to get that energy to do work, right? So I think part of the reason why MSDs occur sometimes is that type of thing is not necessarily understood, and it's getting better, I think, with different types of material handling equipment, and obviously looking at things like exoskeletons and those types of things. I think there's some realization that humans do have limits, physically and cognitively, and if we exceed those types of things based on work, then then that's really why these types of injuries occur. Like if you look at the root cause and we look at the definition of ergonomics, that's essentially what it is, right? If there's a mismatch between the worker and the work environment, then injury is going to occur. So you can see there's some examples there, right? Navigating with a blindfold on, balance with your eyes closed, reaction time, like all of these types of things have limits. And a lot of examples we'll talk about later, we'll talk about how reaction time is a limit that could lead to struck bys, for example, because of our reaction time. If we're expecting the human to react faster than what our capabilities are when it comes to using material handling equipment, for example, then it's only a matter of time to where, things are going to be in the wrong place at the wrong time, right? Or how work occurs in your workplace to where those things come together that injury occurs. So we have to, I think, have a good understanding of really what our limits are. And I guess another issue, and this is more of a challenge, but they occur because hazards come and go, right? Like even in the same task. So you can have a pallet of boxes that you have to take a box up, over your shoulders, and that's uncomfortable. But as soon as you start working your way down the pallet, now you're at waist level and kind of the power zone. We've talked about that before, kind of between your standing knuckle height when your hands are kind of, or your arms are by your side, up until usually around chest level is kind of a power zone. We like to have material where we're doing materials handling. So that might be true for half the task, and then now you're bending over. So of course that's a challenge. So we'll talk about different controls, and maybe people in this safety connection have some examples of those types of controls they've successfully implemented to try to deal with that variability, that hazards exist, then they don't, then they exist again in the same task. So we'll talk about some examples for that as well. Okay, so brief intro to MSDs and kind of why they occur. And that's going to kind of lead into some of the challenges that we have, and into some case studies that we could have as well. Another challenge is that you could have two items, and I'm not suggesting that a 20-kilogram bag of salt and a case of water weighs the same, but let's just for argument's sake say that they do. The challenges of carrying the water, I mean, it may feel easier because of how it's packaged and what the water's like and those types of things, where if you lift a bag of salt, say from the handle, all of that salt starts to settle on the bottom, almost making it feel heavier than it is, right? If you pick it up with two hands, right? And you see, when you buy salt at the grocery store, you see kind of people struggle with those types of things, right? So even similarly sized or items that weigh the same could require different types of handling, right? Or cause different types of risk. And you can make an argument for the water, and let's say because of small containers, it doesn't really have that great of an effect. But let's say it's just one giant container of water that looks like that. As you're walking, for example, that water can be sloshing around, creating more force, right? Requiring us a greater effort to keep it stable because the water is creating momentum, which is then requiring us to secure it more so that we're not twisting or doing whatever in our body. So really what the material is made of and what's in there can also cause or create challenges for us. So that's when, and I think that's a question that we get all the time. Well, how much can I lift safely, right? And there is, I'm sure you've heard of 23 kilograms or 51 pounds, but that's really under, and that number was devised a long time ago in laboratory settings under perfect lifting conditions, right? That's somebody in a lab with a box with good handles lifting under perfect conditions. The box wasn't giant. So we have tools, and we try to say that and to be honest, as ergonomists, we hate saying this when you ask us, how much can I lift? And I say it depends. Like that's not helpful, but you can see based on some of these examples of how those numbers will change, right? So, if we say, well, you can lift, 23 kilograms safely, then, if it's made, if it is water, then, it may not be safe because of how that momentum is moving around and, from that water sloshing around and those types of things. So that's why it's a challenge for us to do that. So it's understanding what we're lifting and how we're lifting it and how many times we're lifting it, that really is going to tell us, you know, to a reasonable level, what would be a safe, or at least I don't necessarily like to use the word safe, but kind of a lower risk lift when you're doing those actions. Um, so really that's really a challenge, and sometimes it takes different unique solutions. You do safe lifting training, but you may need to modify it to deal with some of the different types of products that you're lifting. But we'll get into some of those issues as we move on here. So another example, and you can chime into the chat here, but you know, my friend Sean here is a teacher, but does some personal training stuff. And like, why is he able to lift, these tires? Like, if you want to throw it in the chat, you can, but why is he able to lift this without getting injured necessarily in this particular, right? So if we're asking workers to lift something heavy, like, why is he able to lift 4 winter tires with rims? Which is not really a great, uh, potentially safe material handling, but he's got some weights on the ends with clips. But yeah, for sure. Yeah, training and technique, trained and conditioned, posture. Yeah, keeping a close load to his trunk. He's not moving, warmed up. Yeah, for sure. Trained to do so. Weight is distributed. Absolutely. Like, yeah, yeah, all of you are absolutely correct. Yeah, like has training, posture is great, load is balanced, proper equipment, grip type. Yeah, if you can see, he has straps as well. So he's got straps around some lifting straps around here that you wrap around the bar so he doesn't have to use full grip strength to be able to do that because he's not necessarily training his grip, but different grip type for sure, Paul, that has it. And absolutely, Kara, that's important. It's not a repetitive lift, right? This is not work conditions, right? Like this doesn't represent work. Yeah, not walking or carrying or any of this type of stuff, right? So yeah, this is not an 8 hour. He's not working out for 8 hours, right? He's working out for, half an hour, doing different types of things, not fatiguing his body. I'm sure if he, did this deadlift with these tires, then did another activity that challenged the same muscles, that did another activity that challenged those muscles, that he may injure himself because he's getting fatigued from doing the same thing over and over again, right? So you can see how that repetition even comes in when it comes to doing weightlifting or working out and those types of things. So yeah, like conditioning and training over time to be able to do that, but it doesn't really represent really what work is all about. So yes, on one hand, humans may have the capability of lifting heavy things, but there are all of these other factors that we need to consider that are going to result in potential injuries from doing the actions that we're doing, right? Especially if we're doing a high pace over an extended period of time in our shift, or we're working quickly because we need to get an order out, or the weight is unevenly distributed, right? He's got the same weight on both sides, right? If it was unevenly distributed, then they're more likely, to get injured or put pressure on parts of his back and that sort of thing. So you start to see all these unique factors that come into work or come into play at work that start to, erode our ability to lift items, to lift items, right? And that's why you can kind of see this, but it's all of those other factors, and I know I keep saying this, but a little bit later in some of the controls and some of the challenges, you'll start to see all of the different factors that we need to consider that start to chip away of how much we can realistically start to lift at work that reduces our risk. So we'll get into that as well. And the other thing is we're all different shapes and sizes, right? I mean, that's a big challenge, I think, for a lot of companies that we go into is how do we accommodate all of these types of individuals? How do we accommodate these individuals at work? And it's not like we can design conveyor lines or do whatever to accommodate everyone from Louise on the left to Jeff on the right. It's a challenge, right? So and that's why we look at how can we design for most, right? How do we design for most people? And there's lots of different types of tools that are starting to get released here to companies and being developed and presented, I guess, in a way that is easier for companies to use and implement, which is fantastic, and certainly we'll make sure that we provide you those tools that you can use, in our kind of post safety connection email that we send out. But there's lots of those factors. So what we try to do is we try to design for most, right? So of course we talked about force. There's other other challenges as well. There's motion, right? So motion is a change in position, of an object over time. So really understanding how different parts of the body move in relation to each other is crucial. There's different levers in the body. We'll talk about that in a minute like when you think about levers or leverage, you think about like crowbars and wheelbarrows, the things that try to make things easier. And our body is made up of all of these different types of levers. There's common ones in the body that we'll talk about in some controls, but it's taking advantage of that leverage sometimes to do activities that help reduce risk, right? If we're starting to ask the body to use levers in a different way, then that's where injury starts to occur. Center of gravity is important as well, maintaining balance and stability during movement. So we talked about lifting that water, that if you're lifting that water and you start to, that water sloshing around, that's going to, be difficult to maintain your balance, right? And that stability and, maintaining that proper base of support to keep you balanced. And if you start to apply pressure to parts of the body or you start to become unbalanced, that's when you really start to, contract your muscles to keep that balance. And that's where MSDs can occur. And quite frankly, that could occur, like you don't want that to occur when you're, lifting something down on a ladder, for example, right? So there's some issues here. Equilibrium, kinematics, just about motion and looking at speed and all those types of things. We won't really get into that type of thing. We look at kinetics, and we've talked about that a little bit about forces and understanding those forces. But there's all of these types of things that we need to consider when it comes to challenges with manual materials handling. But the good thing is that for you don't have to go into all of these types of things. I'm just trying to show you that there is some complications here when it comes to us saying, well, you can't really lift this much, or it depends on all these different types of factors. But the good thing is there's lots of different solutions and controls that you can implement right away to help kind of reduce the effects that these might have on or causing manual materials handling injuries. So we'll get to that. Okay, so those are some challenges from a mechanical perspective, from a human perspective, from a perspective that work is really not a linear thing. Things change all the time. Hazards change all the time. So what I'd like from you right now, if you don't mind, and thanks for Emily for launching the poll, is what some challenges do you face? And this is a word cloud. We've had some issues with this word cloud in the past, but if you put your answer in there, then it'll populate. Yeah, perfect. If it doesn't, just like the last last poll. Just throw it in the chat there. But yeah, what kind of challenges are you facing with material handling and or manual materials handling? And I know, as I mentioned before, that that the challenges just from the human body perspective, the mechanics, the force, posture, repetition, those types of things. And I think that's known, but I'm glad I've had the opportunity to give you an introduction to that. But it's really about the work, right? And how do I change work, and what types of things do I need to do? So to do that. So just some challenges that are coming in: bad habits, repetition, aging workers, work demands, heat, yeah, overhead work, not enough people, different heights, yeah, for sure. Management buy-in's a big one for sure. Um, let's see here. Yeah, things are heavy, different products. Yeah, like I've been in warehouses. Yeah, I have 10,000 SKUs or 20,000 SKUs. Like how do I teach lifting or redesign things that are going to make sure I can lift all of those things safely? Jeff's got old facilities, tight. Yeah, absolutely. Old facilities, tight spaces, like lack of space is really a big one. Like you might have things at the right height, but if I need to kind of squeeze between two things to try to lift, that's going to change my posture and put me in a position that might result in some discomfort or some risk. Yeah. Constant changes to job processes. Yeah, absolutely. Work changes all the time. Like work is not linear. Work is, I've had a graphic in the past where work is kind of like all squiggly all over the place, to where you get to the point where you produce your product, right? So, work processes change. And like from a safety perspective, let alone an ergonomics perspective, I mean, work processes change. That's going to change hazards in general, right? Hazards in general are going to change. Now you need hearing protection, or now you don't need hearing protection, or now you need safety glasses, and now you don't. So all of that stuff, hazards change constantly. The work process and how work is designed is going to, maybe naturally eliminate hazards or create hazards that then you need to go out and reevaluate and change for sure. Shrinking workforce, yeah, definitely not enough people to do the work, applying more pressure to people to get the work done. That's going to, create more of a hazard for sure. Okay, perfect. You close the poll. That's awesome. Yeah. So those are some great challenges here that we got work. Yeah, definitely work in general for sure. Um, yeah, those are some great challenges when it comes to navigating the challenges that you have with, understanding what causes MSDs is fine, but trying to relate that to work and how do I change work to accommodate that? And people are different shapes and sizes, and as you mentioned, and all those types of things are different challenges. So we'll try to work through some of those challenges as well to kind of give you some solutions to try to mitigate some of that as well. And of course, it's we're not gonna solve all the issues today. I would love to, but we're not gonna solve all those issues today. But at least hopefully we can kind of give you some insight into some things you can look at to try to mitigate some of those issues. So what I want to get into is some case studies um, and there's just some from different industry here, and I think I have all that. I don't have service here as an industry. I apologize for that as a case study, but we can certainly relate it to lots of examples from the service industry when it comes to MSD challenges. Um, but I want to look at challenges with manual materials handling when it comes to not just MSD prevention, when it comes to lifting, lowering, pushing, pulling, carrying, and holding, but slips, trips, and falls, chemical safety, ladder use, struck by objects. So the thing I want you to keep in mind when it comes to these case studies is maybe how manual materials handling will or potentially could have led to the results of the injury with these case studies. So just keep that in mind as we kind of go through. And of course, we will ask you to to answer if you want in the chat would be great. So there's no polls for these case studies, but just answer in the chat. So, okay, so here we have a 50-pound bag of, well, I should say 23-kilogram bag of flour. And this warehouse worker is about 35 years old, and they're lifting it from the ground and placing it on a shelf, which is approximately 4 feet high. This employee working in the warehouse has been there for 5 years and has no prior history of back injuries. So on a busy Monday morning, this employee was in the process of restocking shelves. They bent down to pick up a bag of flour from the ground. As they lifted the bag, they felt a sharp pain in their lower back. Despite the discomfort, the employee continued to place the bag on the shelf. However, the pain intensified and they were unable to continue working. The employee reported to the supervisor, provided first aid, and arranged for the worker to attend a clinic. The initial assessment indicated that it was a possible muscle strain in the lower back. So if you want in the chat, if you could just tell me what were some of the causes that led to that incident. So just from kind of the description of the rushing, not practicing proper lifting technique for sure, bags low to the ground, proper posture, yeah, for sure, workplace, yeah, bending, continuing to lift, that's an important one, right? Felt the discomfort, but continued. Lack of lifting tools, low posture repetition, absolutely. So like the key to that is busy Monday morning, right? So no warm up, yeah, lack of education, repercussion, yeah, that's a great one. Fear of repercussion, should I report, right? Pre-shift session, use of cart, yeah, absolutely. So these are fantastic. So of course, so when we look at lifting examples like this one, just a straight kind of lifting bag of flour, that one of the things that you can do is as we talked about before with the salt and the water bottles is looking at the item that they're lifting, right? So if you're doing an incident report Monday morning, yeah, absolutely, Keith, that's funny. Busy Monday morning, right? So when you're looking at, when you're looking for hazards, or let's say, unfortunately, we're doing an incident report for this particular example, is that the factors you need to look at are not just, and you've basically said it in the chat, right? You want to look at the material in which they're lifting. So like I said with the salt, is the way in which they're handling the material, an issue, right? And I'll get to the question about stretching. That's a good one because it was mentioned. So I'll get to that after we talk about this. But in the way in which the individual was lifting this material, right? So were they holding the bag at the end, kind of like the bag of salt, right? Or were they lifting it kind of like this, evenly distributed across the arms, right? So you're kind of looking at the material in which they're lifting. You mentioned about, posture. What is potentially causing that posture? Was it, lack of lifting technique training? Was it, fear of repercussion because, they needed to get the order out quicker? There's lots of different like kind of physical conditions, but also process conditions and all those types of things that, that could have led to these issues from occurring. We talk about root cause and those types of things. Like it may not just be the person's poor lifting technique. It could just be all of these other factors that resulted in that person's poor lifting technique. So a great example is let's say they had a pallet with a a pump truck on it, and they needed to, because it was busy, they needed to kind of hand bomb 4 or 5 different bags onto this pallet as they continued to the next slot, let's say, for example. Is that sometimes if the pallet is too close to the pallet of flour, then that gives individuals the opportunity to lift and to twist as they're lifting, right? Maybe it's I'm using air quotes, easier to lift and twist and kind of put it on the pallet. Well, we know twisting, the back is in a very vulnerable position when you twist. So having that pallet too close to the flour, with that twisting reduces our capability, even though it's 50 pounds, right? I said 50 pounds, is safe under not safe, reduced risk under ideal lifting conditions. But you have different uniquenesses here of these bags of flour that are starting to reduce that capacity, right? So once you start, introducing some of that twisting, then now our capacity decreases, and perhaps that's why they lifted it. So yeah, it could be procedures, it could be all those types of things that could lead to uh, uh, this type of injury. So my advice when you're looking at incident investigations or you're identifying hazards that you need to look at, if you're familiar with, I don't know if I put it in here. I think I might have taken it out just because of other things I wanted to explain. But um, the PMIP example, like the brainstorming, right? The people, equipment, materials, environment, and process. Those types of things. Those are items that you can use when you're doing an incident description, or sorry, incident investigation, to identify that, or what are the people factors here? And you mentioned them in the chat, right? Maybe the person was really tall and they had to bend over, where somebody who was shorter was in a better position, right? So there could be people factors there, training, those types of things, or it could be a process, right? Busy Monday morning. They put the pallet too close. Like there's all of these different factors that you can brainstorm and then start to cross those off the list of possible causes, right? Material, obviously, we talked about the material and how the flour might be, um, you know, settling at the end, which may make it appear more, heavier, or, putting additional weight on one side and the other, and that's, putting more pressure on different muscles as opposed to distributing the force over the whole body. So looking at all of those types of things to identify those factors that are leading to that, and you can do that even if an injury hasn't occurred, obviously, is ideal, is looking at those situations and how we can do it. Yeah, and Lee, that's great, having a two-step process, right? And like all of these types of solutions you're coming up with, and all those types of things are great, like great examples, right? Of the process of how we should implement these types of things as controls for that process, right? It's a busy Monday morning. Does the way in which the work is designed and what we need to do to get that material out the door, does that allow for a two-step process? And I know that seems strange, but if you need to do two lifts and you're lifting it to one and then lifting it to another, or I mean, somebody mentioned about lift assists. Like we see a lot of lift assists go unused because there isn't enough time to allow for that in the process, right? So if you're designing like a conveyor line in manufacturing, like there's different, you allow in that process time to weld, time to move it from the part from this location to this location, and then but is there time in the development of that process for the human to do those activities, right? So it's really the design of work. And great point about the supervisor for sure. And we'll get to supervisor's role in controls and lifting and all that kind of stuff in a minute. But stretching, yeah, stretching is, it's, I always use this example, like obviously flexibility and conditioning, like all of those types of things are important, right? To be kind of an industrial athlete, right? But we just had the Olympics, and plenty of athletes unfortunately got injured at the Olympics, right? They're been training a lot, in shape, obviously doing a lot of different types of stretching and flexibility and massage and all of those types of things. But when they were doing their event, they were applying force that exceeded what their capabilities of their muscles are, despite the fact that all of those types of things occurred, right? So when it comes to stretching and those types of things, I'm not suggesting that it's not helpful, but it's not necessarily it if you look at the hierarchy of controls, it wouldn't be the control that would be at the top of my list, right? So it would be something more in kind of the personal, towards the bottom, right, of personal controls and those types of things, right? So encouraging those types of conditionings and all those types of things are great, but if you're lifting 50 pounds, bent over at the waist, and it's in front of you and you're increasing that force posture repetition, then those are the types of things that are going to put pressure on your back and create issues, right? And not the fact that you have stretching is not going to help you overcome those types of things. So it's a great question, but I can make a note and send some of those information about stretching to the group in a post webinar. So I'll ask this poll question. And then I'll just make a note of that right now so don't forget. But do you consider, so when you're doing, health and safety in general, right? Do you consider manual materials handling as a cause of falling, tripping, or struck by? So what we're trying to do is we're trying to, part of, we talked earlier about a different poll question about management support and, like ergonomics and MST prevention, like there are a couple things in the Health and Safety Act that talk about, or at least we can interpret to talk about ergonomics and material handling. In the industrial regs, section 45 talks about it. So there are some things in there that we can use, but by and large, there's not a lot about ergonomics and MST prevention, which is hard for us to convince customers. Obviously, talking to individuals that are on the same boat as us, of saying, look, MSDs are 35 to 40% of all injuries. We need to concentrate on this, yet we're always in competition with compliance-based activities, right? So if you have to guard because it tells you, and of course I'm not suggesting that you pick one or the other, but risk assessment is important, but you guard because it says in the act you need to guard, or you need to do this or that, or do a pre-start health and safety review, all those types of things. So you tend to concentrate all your stuff on that type of thing, right? So always in competition with compliance based. So what we're trying to do is trying to make those connections between how does manual materials handling itself potentially cause falling, tripping, or struck by, or other types of things. So as health and safety professionals, can we use ergonomics and MST prevention, activities to help with preventing some of those things? So we got the majority of yes. So close the poll. I'm just going to make a quick note about stretching because I promised that. So send stretching info. Good, 81. So most and some say no, some say not sure. Okay, so let's go through some case studies to do that. And Catherine, yeah, if load is heavy, awkward, blocks person's view, all that kind of stuff for sure. So let's go through some of those case studies. You could just tell me, what, again, same as the last one, what types of factors may have led to this issue. So there's a 28-year-old seasonal worker was employed at an apple orchard during the harvest season. They were working there for 3 weeks, responsible for picking apples from trees and placing them in these large baskets. This is timely as apple picking season is already underway. So on a sunny afternoon, the employee was picking apples from a tree, reached up to grab an apple from a high branch, standing on their tiptoes, and pulled the apple, lost balance, and fell, landing awkwardly on the ankle. Immediately felt intense pain and was unable to stand. So what are some of the factors that led to this individual falling? So this individual fell. Sorry, I didn't say that they're on a ladder, but they're on a ladder picking up apples from a high tree. So just in the chat again, what are some of the factors that led to this person falling? Yeah, new worker. Yeah, no problem, Amanda. Just throw it in the chat. New worker, balance, seasonal. Yeah, reaching. Ladder height too short for sure. Lack of 3-point contact, absolutely. Yeah, wrong tool for the job. 3 points of contact for sure. Unstable ground, yeah, absolutely. Reaching outside of kind of your core, yeah, the ladder base, yeah, for sure. So yeah, like you have it for sure. Like so when you're categorizing this, for example, tree was too tall, yeah. We got jokes today. This is awesome. Usually I try to sprinkle in a few jokes here, but I don't need to. You guys are the best. Tree was too tall Monday morning. This is awesome. So yeah, absolutely. Like so when you categorize this, like if we get stats right from from safety check at WSIB or stats that we try to figure out, like what is leading to this, like you may categorize this as a fall, right? But for us, you kind of gave all those factors that it wasn't because it was a fall, but the cause of it was a manual materials handling issue, right? The equipment, the individual, the training, the three works, like the sun, right? Maybe the sun played a factor in if the sun is right in your face and you need to kind of turn this way to see what you're reaching for, so it's not in your eyes, like that could be a factor. I've talked to a friend of mine, who's a ministry ergonomist, and they investigated a fatality where sun played a role in blinding the person's vision from seeing where they're going. So there's lots of different factors here that led to that fall, and it was because they were handling material, right? Were they, we could speculate, but were they wearing, a harvesting, backpack, right, with pouches on the side? Was it evenly distributed? Were all the straps then up? Were they holding a bushel, right? Standing on the top level of the ladder, right? Uneven ground. Like these are all factors that resulted in this particular injury, right? So for me, it was and for all of you, as you said, it was the act of manual materials handling that led to this. So we got half an hour. I'm just going to roll through these a little bit quicker. So this is a barrel of chemicals. This person was transporting this barrel. It fell and spilt chemicals all over the place. Although this is probably wine or whiskey in here. Let's just say it's chemicals. So it's a chemical. It's a chemical spill that opens up a whole bunch of different types of things for health and safety. So you categorize spill chemicals. You have to have policies and procedures in place to deal with, handling chemicals safely. But again, in this scenario, it was the individual having to handle a material that was full of liquid that created more of an effort and resulted in a spill, right? So it's really the material handling of it that created those issues, right? So similar to our water example before. So, chemical safety is, what the ministry is looking at right now as far as one of their campaign topics, right? So, chemical handling and all those types of things. And I get the chemical handling part is really, some other things like decanting and storage and labeling and all of those types of things, right? But at some point, the human needs to potentially take those things, transport it, or do whatever they need to do, right? And if things are too heavy or they need to transport things in bulk or they're not using carts or they're rolling it, whatever it is, like all of these types of things are required to be looked at that are going to prevent those spills from happening in the first place. So it really was a material handling issue here that led to these chemical spills, right? Another one was somebody just carrying. Sorry, I don't have a great picture. Usually, Getty Images or images that are part of your Microsoft PowerPoint are full of hazards, and I'll show you a great one in the next example. But again, somebody mentioned it earlier about handling a large box. You can't see where you're going, right? So you trip on a pallet or you trip over uneven flooring. So really the act of manual materials handling, even though the box was, fairly light, it's the size that impacted their vision and led to those types of things, right? So in our mind, it's, in recording the incident, they tripped, they fell, they hurt themselves. But in reality, it's because they couldn't see, they're handling material that was too large. So it's a work process or a thing that the material handling thing that needs to change to make a difference here. Okay. Here's a fantastic example of, like I said, with those material handling things. So another example is tire changing. So I don't love it, but I feel for the actors in this picture, because you have somebody changing a tire, on a jack, I don't know, this jack is holding up the vehicle or these jack stands are holding the vehicle, but you have somebody in the car could potentially be shifting this around that could fall on this guy or this person, sorry, underneath the vehicle. So this is not a fantastic a fantastic picture, but I guess a good one for examples here. But think about tire changing, right? So tire changing season is coming. I can't believe I just said that because it's been so nice in September, but tire changing season is coming up. And normally changing tires, like there are issues with it, but the one factor that's going to change is frequency, right? So come October, November, like it's going to be back-to-back tire changing all day long, right? The fatigue of transporting tires, getting them out of storage, bringing them to the vehicle, lifting them onto the vehicle, doing them up and, changing rims and like all of the things that go on with tire changing would certainly increase that risk, right? And I get it, like putting the lift down, taking the wheels off, putting the tires, raising the lift up again to a different position, like all of those types of things I get start to increase the amount of time it takes to change those tires. So in summertime or just changing a flat or like doing whatever, I get that that's a possibility. But in wintertime, it's a little bit more of a, or sorry, tire change season, it's a little bit more of a challenge. So that's why with, we'll kind of go through some controls a little bit later, but that's why, there's different factors here that we want to consider to try to reduce that overall risk, right? Do we, have somebody changing tires for a certain period of time, they rotate to do something else and you have somebody else come in, right? The way items are stored, do you have a tire transport dolly that you can transport all of the tires, to a location all at once instead of hand bombing them? Or, I've seen carts that will lift the tire onto the wheel itself, kind of at ground level like it is here, as opposed to, different robots now that you can have to actually put the tire on. So we are actually meeting with some different tire changing shops actually, and another the Ontario Tire Dealers Association actually this Friday, because we are looking at creating some resources around implementing ergonomics with tire changing. So and even roadside changing as well, if that's kind of your what you do as well, of changing tires on the side of the road and different hazards with that, not just ergonomics, but other hazards. But that's something that we are working on as well. So look out for that as well. Another case study. So you have somebody handling material. They're pulling this material backwards across different aisles, and they get hit by a forklift. So struck by, right? So the fact that this individual's pulling, backwards, it's hard for them to see behind them, right? So, and then a forklift is coming down an aisle and hits this individual, right? So really the act of handling this material is in part to blame for this struck by, right? Why are, we can talk about pedestrian safety programs and, why were there employees in this area when they shouldn't be, and where the forklift was, but there are unfortunately examples of the fact that struck-bys are occurring because operators can't see the individual, right, or coming around a corner and hitting that individual, right? And of course, intersections and mirrors and barriers and all of those types of things are important to control the flow and separate people and machines. But the fact that the material handling or main materials handling led to that struck by. So making sure that you're able to, or you're not discounting the fact, the ability for not just the let's say the forklift driver, but the person doing the manual material handling to see where they're going. And we talked about that with the carrying the box, right, and tripping over things. So if they can't see, or something is obstructing their vision, then there's issues there as well. And there's some human factor stuff as well. Like if that forklift driver wasn't expecting people to be in that area, then there is the likelihood that there's more of a likelihood that they would not notice that individual and hit them, right? If they're expecting people to be there, then they're always vigilant, right? So it happens where I live in Waterloo region, where we have all these roundabouts, and there's not really a lot of pedestrians, right? But now they're starting to build a lot more houses and all that apartment buildings, and there's a lot more pedestrians now crossing. And you see all the time pedestrians are waiting because there's been plenty when they first got in of pedestrians getting hit by cars. Um, but now you start to see a lot of cars drive up and stop right away because there's a pedestrian. They're not expecting them to be there because the hundreds of times they drove by before, people weren't there. So, those types of factors can play into some of these struck by things. So line of sight, making sure people know that they're in there, seeing people would help to reduce some of these struck bys and by a cause of main MTILS handling. And maintenance on the pump cart, for sure. Is it hard to operate, right? Do they need to push in, just from using it? Are they rolling their shoulders, which is, curving their back as they're pushing, right? Wheels appropriate. You have a lot of forklift traffic that can start to create potholes in the floor. And is that, not just creating vibration for the forklift, but causing more of an effort for us to push or pull. I'm not going to look backwards and pull heavy. I'm going to keep everything aligned and pull. So now I can't see anything, and that could be creating some issues. So, yeah, there's different procedure things for sure, honking the horns, all of those types of things, right? But we see all of those types of things, but how can we design our workplace and our process to where we don't always have to rely on the human to make the right choice, right? The human is like, there's plenty of times in our workplaces right now that the human is making the right decision, right? They're always making the right decision, but there are factors that, for whatever reason, they make the wrong decision, right? Or they don't notice something, or they thought one thing, right? And there's an intersection here where I live that, there was a collision because they just thought it was a through street based on the design, and it wasn't. They had a stop sign and somebody went through and they T-boned, right? So there's reasons why they made that decision, because they interpreted the environment a certain way, right? And you don't want that to happen with some of these things. So it's important to kind of look at all those factors as well. Okay, and consider all those factors. So yeah, I plowed through those, but hopefully that's an example of when you're looking at other safety issues, like where are the different main MTILS handling factors that potentially contributed to that, and that's just more of an incentive to deal with some of those main MTILS handling issues, to hopefully ensure that it's or not ensure, but make sure it's contributing to the controls of some of those other things, like the spills or the falling from a ladder and those types of things. So like in ladder safety and training, for example, here we talk about 3 points of control, right? So not just 3 points of contact, but I could have 2 feet on a ladder and 1 on the ring and be reaching, right? And kind of stretching out right as I'm doing it. Well, I'm not really in control, right? My grip could give way because it's fatigued, and then I fall because I'm trying to reach for something, right? So, and somebody mentioned about being in within your kind of stability zone for that ladder, for example. So making sure you have 3 points of control. But I want to use the last 20 minutes to kind of go through some practical strategies and those types of things. So for you. So these are the common things that we see. So I want to give you some common things that we look at when it comes to main MTILS handling. So I'll roll through them because I want to get to some more practical strategies, but here's some things we look at. So when you're looking at main MTILS handling, grip is a big one, right? So what type of grip they're using, whether they're bending their wrists, this way, like all of those types of things should be indicators that if they're in poor positions, that you're going to start to see an increase in risk in main MTILS handling from grip. And wrist position, as I just mentioned, shoulder angle as well. So if our hands are, if our elbows are at 90 degrees and we're pushing, that shoulder angle is more of in a neutral position, And that's the best position we like you to be in when it comes to those types of things. Anytime you start to bend the shoulder up or start to reach out or start to reach back, the the shoulder starts to get into vulnerable positions, right? So reaching back like this and applying a force, a lot more strain on the muscle, and we start to see some issues that way, right? So that's why with material handling or manual materials handling, we like, things to be at this position so I can push without putting the shoulders in that vulnerable position, right? So keeping that shoulder angle in there. The other thing, things that are a bit too heavy. So in some environments where there's lots of very heavy things, workers choose, or part of the process is, well, of course we need something to help us lift that. It's too heavy. We just can't physically do it. So that's an easy solution. Same with really light things, right? If things are really light, maybe we look at how many times they're lifting and what type of posture they're in. But it's, we find when things are just a bit too heavy that we're like, nah, I think I can do that, right? And that's kind of where those injuries potentially we start to see some of those injuries creep up when things are just a bit too heavy. So so looking at things that are kind of around that weight level that I think I can do that. Grip strength, reaching, balance, we talked about, rounded back. There's some great posters actually on the MSD Prevention Guideline website. We'll include that in the follow-up email, but msdprevention.com. There's some great posters about different lifting postures. So, rounding shoulders, having the knee bent in, for example, as you're lifting, rounded shoulders when you're pushing. So all these different kind of nuanced postures of the different joints that as you're doing those actions are putting ourselves in vulnerable positions. So you can look at those posters, use some of those posters and have them up in your workplace, for example, to show, different postures and how you should be in when you're pushing them. Because you can have one item that is, easier to push with kind of straight posture, but harder to push because you're all rounded, right? We talked about cannot see where you're going, using the lever in a different position, different work pressures, those types of things. Okay, all of those contribute to material handling. Okay, so I just want to kind of go back to these challenges here. So the takeaway from those case studies are design of work matters, right? It plays a major role in those hazards. So like I said, all of those examples that you posted in the chat, a lot of them had to do with how that work was designed, right? Change in processes changes, then whatever we had in place that might have made it a safe manual materials handling now made it worse, right? So it does play a major role in the hazards. So how do we get to that level of management commitment to incorporate ergonomic design into how work is designed so that people are in they're the best possible position to do those tasks, right? And as we've seen with some of the case studies is that hopefully implementing some of those things helps to mitigate the risk of individuals falling or getting struck by or tripping, right? So those factors of implementing ergonomics has helped us with that. So it's almost like a 2-for-1, right? You've implemented ergonomics to make things, better for me to lift and push and pull. But if I've done it correctly, then hopefully it's helped contribute to falls. And so if you're looking for management support, there's a way of saying, if we design this to accommodate most people, then hopefully it's reducing our overall risk, right? Tasks that overlap leading to new hazards forming, then disappearing, like how work is designed, all those types of things can occur, right? And we talked about, there's different ways of doing the same thing, right? There's different ways of doing the exact same thing. So like we said about lifting the flour, there's different ways of lifting the flour that, in some ways may reduce hazards, in some ways may not, right? So there's all those types of things here as well, okay? And we know that solving these issues are complex, right? I mean, that's why we're all here, and that's why we did the safety connection, is to try to give you some simple ideas of how to solve some of these complex issues. And there's lots of different layers and all those types of things that exist. But I want to kind of give you 4 focus areas, and don't worry about this kind of chart here. I know it's kind of all over the place, but I'm just going to focus in on some of the highlighted things here as well for you. So So I want to give you some kind of, like I said earlier, some of those practical strategies to reducing some of these types of things. So this is hazard identification and risk assessment, right? So that's obviously important. You want to identify some of those hazards. And I gave you hopefully gave you some idea of what types of things to look for as far as grip goes and different postures you might be in, to help you identify hazards. Again, that doesn't necessarily mean that there's risk. And that's, I think, where things go, unidentified sometimes, is that, well, I'm reaching and nobody's getting injured, so there's no issues there. Of course, that's a way of doing, kind of an assessment to a degree, kind of a simple assessment. But if I know that I'm reaching with my shoulder in this position, applying a force, I know that there's some risk there. There's some vulnerability to that joint there, right? So it's just merely identifying those hazards and then using something like this REBA, and I'll send you some tools, some screening tools we call them, just to help you prioritize where some of these actions might have some consequence down the road, right? So if I am reaching and I'm pushing, a screening tool like a rapid entire body assessment like a REBA is going to assign a score that say that, that's not the greatest position to be in. So maybe that should be a little bit higher on your list to see if you can make some changes. So there's different screening tools like that. We have some free MSD hazard checklists that you can use to help you with that. And there's kind of more specific documents that we're creating that you can utilize to help you identify some of these hazards as well. And of course, review the environment, how that's contributing to my hazards, and look for other elements of manual materials handling that might be an issue, right? So all of those strategies and the work process and those types of things to help you identify hazards, that's really the key. And then you can apply that to these different types of screening tools to say, okay, so I have all of these hazards. What factors are going to start to increase the risk that something might occur, right? So, I see somebody pushing, they have a straight wrist posture, right? I see another person pushing, they have a bent wrist posture. I'm gonna look at the bent wrist posture first and see why are they holding their wrist in that position. I know that that's going to potentially increase risk, right? That's going back to our force posture repetition. Are they grimacing? Is there a lot of force? Are they in awkward postures, reaching overhead? All of those types of things. Are they doing repetitive things that is going to lead to hazard? So I encourage you, as a practical strategy, just to do very simple hazard identification using a screening tool like REBA, other tools to help you prioritize those hazards of what to identify, and then concentrate on those elements. So, if it is a bent wrist, how do I get the wrist a little bit straighter? And of course, you can go into internal assessments if you need to, using some simple assessment tools. If things are a little bit more complicated or require have a ministry order, all those types of things, then you might need to require an external assessment by an ergonomist to do that as well. So just some strategies to kind of get started to identify some of those hazards, right? And you can see I've included some of those posters here, some examples of posters of just different postures that kind of lead to those types of things. Some other things that kind of make those things difficult are, and you mentioned some of it, and I mentioned it in the past, but just to kind of go through it again, floor conditions, load characteristics. We talked about like the water example of kind of going over that a few times, repetitive handling, whether you're twisting. Somebody mentioned space restraints, right? Space restraints can change what I'm looking at. So, even though you've had training, you've taught people to lift properly, things are organized in the right position, the environment can dictate what type of posture I'm in, and twisting and all those types of things. So making sure I've taken care of those types of things is important as well. Somebody mentioned the heat. So having a hot work environment, even a cold work environment, like if you have a freezer or something in that cold work environment, or working outside in the summer or the winter time, especially in the cold, changes our efficiency, right? The blood starts moving away from our extremities and may make it difficult to grip things. Maybe we have to apply more force, right? So there's different types of things like that. So when it comes to manual tools handling. Okay, so for training, so some practical strategies with training. So no mention people talked about, proper techniques and, making sure they're not overreaching or on the top step of that ladder or whatever it is. So, one of the things that for whatever you want to teach, or you have somebody teach your employees, is a good technique is an acquired skill, and it takes practice, right? So lifting training is great, understanding kind of the theory, the mechanics, and making sure that you're in a good position when you're lifting and utilizing that leverage in those body parts in a way that is going to help reduce some of that risk. And again, training is a little bit lower down on the um, the hierarchy of controls. We have some other ones coming up here that would help to eliminate the lifting altogether. That would be great. Um, but it's just that continuous practice, right? That continuous practice of lifting is important. And a lot of our lifting training, for example, shameless plug, but our lifting training, for example, we encourage the supervisors to be lifting coaches, right? To train those individuals over and over and over again, because we'll come in and train, and we'll train to things that workers are actually lifting, but to then we're gone, right? So unless you want us to come in and try to reinforce some of those techniques, but utilizing supervisors to continuously reinforce some of those training, do tailgate talks, all that kind of stuff to say. Or pre-shift talks to say this, make sure you're lifting this way, or make sure you engage your core, have good balance, and those types of things, right? Just to reinforce that technique over and over and over again, so that so workers are doing those types of things continuously. So that's important. Ensuring that you're applying lifting or any manual tools handling techniques in variety of workplace conditions is essential, right? So yes, we'd all love to apply proper techniques, be in a good position, but as we saw with the flower, like work, again, like I said, work is not linear, work is changing. Monday morning rush, like all those types of things that have to train people to lift in varying conditions. How do I lift something safely overhead, right? Again, we prefer you not do that, but we understand when it comes to training that unless the work environment changes and the work process changes, how do we apply the lifting skills in a way that is going to try to make that lift as safe as possible, right? So again, not advocating that as your top control, but I'm just talking about reality sometimes, right? Sometimes we have to lift overhead. So if we can control some of those factors, great. That's the hierarchy of controls. Let's eliminate that. Let's try to change how things are stored, or put lighter things overhead and heavier things down below, and all that stuff is great. But there may be some instances where we can't do that. So let's try to get individuals to lift things correctly. Um, yeah, and adapt that training to those changing work conditions, because that changes all the time. Okay. Um, as far as purchasing, so the other factor, the third factor we want to look at is purchasing guidelines. So we have doing a risk assessment to identify where our hazards are. One of those things we may suggest as control is training to make sure we're able to handle that material properly. So that's the other thing. The third thing could be purchasing guidelines. So are we purchasing equipment that is suitable for the task that people are doing, right? So we are using a cart. It's got the wheels that are appropriate, or the casters that are appropriate for that work environment. So it's easy for me to push. I'm not, pushing uphill. If I am, there's different equipment that allows me to do that a lot easier, right? If I'm outside, I have the type of wheels on a cart that's appropriate, right? If I'm pushing in a field with mud, I have big tires that are able to roll through that mud correctly, or in a greenhouse, right? As opposed to, smaller wheels, harder wheels that are going to then make it more difficult for me to look at. So again, implementing some of those purchasing guidelines to eliminate some of those issues. And some of you may already do that. You may already do that with some of your purchasing guidelines. You just haven't, maybe you haven't realized that the cart you did purchase is actually preventing MSDs. Maybe you haven't had any injuries, but look at it that way. You've purchased a cart because you're requiring somebody to move an item from point A to point B, and they're just doing that, and that's a normal part of work. Well, in my mind, that's an MSD prevention activity. So if you didn't have that cart and they had to carry, then you'd have MSD hazards. So you want to incorporate those types of things into your purchasing guidelines so that you're getting things that aren't introducing MSD hazards into your workplace. And you see some examples on the side about how to do that. Employee feedback is critical, right? It's critical to get employee feedback to ensure that that material handling equipment is appropriate. Okay. Some practical strategies: start small, leverage existing resources. There's plenty of cost-effective solutions that you can go through. Okay. I know I'm rolling through this because we have 5 minutes. I like to chat if you've been to some of my safety connections before, but I'll make sure I include some of these types of things in some post safety connection emails. So task and equipment design, again, just looking at either new tasks or equipment and how can you design standards into that to reduce hazards, right? This one's a little bit more difficult to do, but you might be able to do that for existing tasks and equipment or new tasks and equipment as well. You have to do a PSR on a machine, incorporate ergonomics into that PSR. I know it's not there as a requirement, but you can do that to make sure that it's designed appropriately for me, as a worker, okay? Okay, I want to get to some practical strategies. So we have because I promised you some quick examples. So you can have, if you have let's say one of those pails from a home improvement store, you have that little handle. You can get a handle that's thicker, so you're now using a stronger grip, right? As opposed to something like this. You see those ergo tools all over with different types of handles. You can do that. If you're in warehousing or shipping, you have those handles, they're probably, I don't know, 6 to 8 inches long on the back of trailers, that some of those trailers, you have to kind of lift it out and up to then unlock the trailer doors and have those trailers swing over, right? I've seen some trailers parked on some uneven pavement that make that activity difficult. So get a handle, a longer handle. I've suggested to some companies just a piece of steel, obviously make sure there's no sharp edges, a piece of steel that's longer. You can put it over top of that 6 to 8 inch handle. Now you have a 12 to 16, length handle, and now you have more leverage, right? You can have more leverage to open that, that trailer door. So using leverage to your example, right? Different handles on tools. I've seen air cushion for sheets. We suggested that, lifting heavy sheets of steel from one location to the next is difficult to grip. So we suggested using just an air compressor underneath to lift those sheets up to grab and then slide them over. Powered cake decorator, there's grip for drywall lifters, there's appliance straps, different casters that we used, making sure that roots are clear in good condition. All of those types of things are help to reduce some of those hazards, right? And just making sure that you're following that hierarchy of controls that I think we're all familiar about, right? Control those elements that are making things difficult. So our flour example, if we can move the cart a little bit further away so I'm not twisting, then that's part of our training, right? This is where the pallet goes, that you need to turn to place the pallet on so you're not twisting, right? Are there other effective or redundant controls that I can implement to ensure that I'm not putting myself in harm's way, right? Our apple picking example, is there a different type of ladder I can use so that it's impossible for me to get on the top step and reach for that apple, right? So you're manual materials handling, but you're preventing falls, right? So there's different examples like that you can use. Again, here's the msdprevention.com. Here's my contact information. Here's how WSPS can help. Just go to our website. We have some complimentary consulting, different training, certifications, those types of things that we're more than happy to help you with. But I'll put my contact information up here. If you have any questions about the content of the safety connection, you just have a situation that you need some help with, I'm happy to discuss, or any of our kind of 9 ergonomists across the province that want to help you with, we're more than happy to help you with that. Even if it's a photo and say, hey, like what's going on with this? How can you help me out? We're more than happy to help you out with that. So I appreciate your time this morning. We did record it, so we will post on our website when it's ready. And again, I'll send a post Safety Connection email with resources, references, tools. Some of the things I kind of glossed over, I'll make sure I put that into a document for you as well, so you have that as well. And I look forward to speaking to you all again. Just make sure you check our website for different safety connections coming up in the future. I know for me personally, I have one coming up in November on the update on the the material handling campaign with the Ministry of Labor. So look for that on our website as well. Thank you again, and have a wonderful rest of your week. Hopefully it stays warm, and enjoy the fall season.